ahead and get started. So hello, everyone. My name is Berta, and I'm with the Gitcoin team. And thank you so much for joining the LUKSO Standard Proposal Workshop. This session is the first part of a two-part series of workshops to learn about the new smart contract standards on LUKSO. So with us today, we have Jean, Yaman, and Fabian will be joining us a little later. They're all from the LUKSO team. And just a few things before we get started. So first, this session is being recorded, and you can watch it on the Gitcoin Media channel. There will be a LUKSO build-up playlist on there, so you can find it on there in case you miss it. And feel free to post any questions you have in the Q&A section. We'll make sure to answer all of those at the end of the session. And last, just please do say hello. Let us know where you're watching from. It's the best way for us to get to know each other. And with that, I will hand it over to the team to get started.
Okay, hello everyone, and welcome to this first workshop series on the LUKSO Standard Proposal. So before to get started, we're going to briefly introduce ourselves. So my name is Jean. I'm a smart contract engineer at LUKSO.
Yeah, and I'm Yaman. Glad to have you all here, and thanks for joining.
Cool. So today we're gonna go through the first set of LUKSO Standard Proposal, and we're gonna start before to really deep dive on LUKSO to have a bit of a background of why we have these new set of standards at LUKSO, and to understand really what's a problem that everyone here we are facing when we use blockchain technology. So as I said before, to really talk about the LSP standards, I want to discuss a few issues that at the moment in the blockchain space we are all really experiencing. And this issue, it's mainly around the user experience. And I think you might all know that blockchain as a technology, it's a very difficult technology to understand. There's a lot of terms, like it's heavily based on cryptography. And for people who are new to the technology, it's quite complicated to use. In particular, because there's like a lot of very technical terms around cryptography, like externally on the account, private keys, and for people who are new to that, it's a fairly new concept. It's really not easy to get used to. And one of the main problems, and one of the main things that we are seeing at the moment in blockchain is that this technology, and if we look at Ethereum, for instance, and the current use case and application, we can see that dApps and protocols at the moment is mostly oriented towards tax and finance. And we have seen that over the course of the last 5 years. It started with ERC20, the whole wave of ICOs and token and ERC20 tokens, and then we have this ice, what they call the ice age, and then everything moved more towards more different applications like DeFi's, DAO, and it feels like we are in blockchain. Everyone is sort of moving at its own pace, and we are all learning as we go with standards, with this new technology, and how we can use it in different use cases. And what we want to do with at LUKSO and with this new set of standards is that we basically want to target a new type of audience. It's what Fabian was mentioning yesterday in the first talk. We want to target what we call the creative economies, and meaning like an audience that we want to target more everyday users, basically, like people who are using an application in industries that are more that are more in applications that are more relevant to us, things that are more meaningful to us. So things like around fashion and lifestyle, or influencers around social media, or people who are creating contents, or artists who are creating also their own creations, and also trying to use the technology, blockchain, and account-based contract to target more for brands that they can use them to basically create really new user experience. And so if you want to do that, if you want to target this new type of audience, what we really need to do is instead of trying to teach people how private keys and externally on account work, we need to find a new way to create a user experience. So what we are trying to do at LUKSO with the LUKSO standard proposals is we need to change the user experience of using blockchain technology. And it's only around interacting with over addresses and over contracts, and it's also a new way to holding and transferring values. But if you want to do that, basically, we need to create a new set of standards, a new set of tools, and we need to create a new set of what we call building blocks, so that we can use these building blocks to build new form of application, and really to create more custom, more user experience that are more targeted to this new audience. And how we are trying to do that, how we are doing that at LUKSO, is by creating a new set of standards that we call LSPs. And LSPs stands for LUKSO Standard Proposals. And so if you want to get an idea, if you want to look at the LUKSO Standard Proposal, the best way to look at is to look at the and LSP repository on GitHub, and you will see this list of standards. And to break it down into a more digestible form, because we are currently at 12 standards. Basically, we can categorize them in different segments, in different topics. We can categorize them as follows. In blue, we have standards around blockchain-based accounts. In purple, we have the standards that relate to tokens or to NFTs. In pink here, it's more around notification service. We will see around the universal receiver. And then we have control and permissioning with a key manager, and we have what we call the LSP2 JSON schema. And it's basically how we represent data, and we interpret data on a smart contract. So you can see from this picture that the LUKSO standard proposal, we can really split them into these two big categories around blockchain-based accounts, token, and NFTs. And then we have these three separate standalone standards on their own: LSP1, LSP6, and LSP2. And before we go into the standards, I'm going to leave it to Yamen to give an overview of the background of the LUKSO standard proposal and on ERC 725 and on ERC 725. Yamen, it's all yours.
Thanks, John, for this amazing introduction. I'm going to start with the background and ERC 725. So first, I'm going to start with saying the problems of the external owned account and identity. So on the blockchain, currently on the blockchain, we use these addresses to interact. And basically, the first problem with these addresses is that we cannot attach information to them. So we cannot attach information such as your name, a profile picture, or other information that we may find useful. The second problem that we have is that we use these addresses to hold assets on the blockchain. And we know that these addresses, these public keys, are being controlled by a private key. So if this private key is lost or leaked, all of our assets will be gone. And this is not the ideal security that we want to have on the blockchain. So the solution of this would be with smart contract-based account. With the smart contract-based account, we can have upgradable security. So that means our smart contract-based account can be owned by an externally owned account, or even by a custom contract that require 2 to 3 signature in order to execute a transaction. And why it's upgradable? Because like if you find this contract not secure enough, you can always change it to another contract that like maybe require 8 signatures. So we can always change the owner of this smart contract based account. And the second advantage for smart contract based accounts, it's building identity. So you can at the same time build your identity, and it's through attaching information to the smart contract. So if you have a smart contract, you can attach information such as your name, a link to a profile picture, or even other information. And a standard that formed the base for smart contract-based account is ERC 725. So ERC 725 was proposed by Fabian back in 2017. It's formed from 2 substandards, ERC 725X, which is a generic executor, and ERC 725Y, a generic data key value store. So the same concept of ownership applies to ERC 725, so it can be owned by an externally owned account or by a custom contract that you can create. So with ERC 725X, we can interact with other contract and addresses on the blockchain, and we're going to compare the operation that an externally owned account will give us and ERC 725X. So with an externally owned account, we can perform only 2 operations, such as call. So with call, we can interact with functions on smart contracts, and we can also interact with addresses, so by sending native coins. And with create, we can create smart contracts on the blockchain. If we go to ERC 725X, we will see that we're able to do much more operations. We have call and create, also create 2 static call and delegate call. So we're going to move on to ERC 725Y, and basically it's the standard that will allow you to attach many information to the smart contract across the time. So on the left, we can see a smart contract where we hard code some variables such as my name and my age. And once this contract is deployed on the network, we cannot add more variables. So we're just stuck with this amount of variable. We can change the content of these variables, but we cannot add more. And if we see here on the screen ERC 725Y, we just have one state variable, which is a mapping of bytes 32 data keys to bytes data value. In this way, even if the smart contract is already deployed on the network, we can always add bytes 32 data keys, and we can add whatever data value to them. So this will allow us to store our name in the contract, a link to a profile image, 3D avatar. We can link followers, addresses of the assets we own, etc. Anything. So just to give a summary of ERC 725, with this standard, we can have upgradable security. So the owner could be anything that we want. We can execute more operation than the externally owned account will allow us to do. We can attach many information across the time with ERC 725Y. And if you want to find out more about ERC 725, you can see the specs in the ERC 725 Alliance organization. And if you want to have more high-level overview of ERC 725, you can go to docs.luxo.tech and view this page. So using ERC 725Y alone will introduce a problem. So I will let Jean to explain this problem and tell you the solution with LSP2 ERC 725Y JSON schema standard. To you, Jean.
Okay, great. Thanks a lot, Yamin. So now I'm going to go through the first standard from LUKSO, which is LSP2. And it's a fairly complicated and not so easy to use standard to understand at the first place, but we're going to go through it in digestible pieces and to explain what's really the purpose of this standard. So as Yamin explained, when with smart contracts, they do a better job at representing an account-based contract. And with ERC 725, we have this very generic contract that has these two generic functionality to interact with other contract and also to attach more information to it. So basically, with ERC 725Y, we already have improved basically our account on the blockchain. We are now more able. We can do the same thing that an externally owned account can do, plus even more. We can even create contracts with another operation type, like create two, and we can even do different type of operations. And on top of that, most importantly, is that we can attach as many information as we want with ERC 725Y, and we have a storage that is more structured. So if you think about this picture with any account-based contract, you define state variable in it. They are when you deploy the contract status layout is basically set in stone. This is very bad for interoperability, because you have contracts that have different storage layout. While with ERC 725Y, we have the storage layout of our contract looks more like this shelf. We have entries that represent data keys and values of what you store inside of all these boxes. So ERC 725Y already helps greatly to use a better contract storage. But we have a main problem, really, with that is still remaining with ERC 725Y, is that the storage of a contract, even if it's better structured, it's still extremely hard to work with. Why? Because let's take a look at this code. You can see, as Yamen was showing before, this is a mapping of bytes, 32 to bytes. So that means that everything in the smart contract is represented as bytes. So for the smart contract, it's fine. For the EVM, it's fine. But for us as human and for interfaces, it's very hard to work with. And let's look at the first example. If you have this data key and this data value, this is bytes. For the contract, it's very fine to understand. But how about us? What can we understand from that? What if you look at this data key? What can you infer? You can ask yourself the question: what does this data key represent? Is it something important? Is there some important information to it, or is it something that it can be shared publicly? Is it something that you should keep a secret? So when you deal with data keys as bytes, you have no idea really what you are operating on. And the same for the value. When the value is in bytes, you don't know how you should decode it. Is it like a number? Is it a number as hexadecimal? Or is it, for instance, an encoded piece of text? So when we operate on bytes, the first thing that will come up is that we basically have no idea how to deal with the data. And the second example is that the second main problem is how we organize this data when we have everything in bytes. So let's take the example again of ERC 725Y. In ERC 725Y, every value is mapped to a data key. And the data key, you can represent it as an analogy, as I showed, a set of boxes where you put the value inside the box. And if you put this value inside, if you put label in these boxes, the label will have the data key in it. But it's still the same problem. We don't know. We know that we have boxes. Some are bigger, some are smaller, some have more values inside them, some have less value. So the storage has the values in different places, but we don't know what is what. We don't know if some data relates to another data. We don't know if this data here on the right relates to this one in the middle. We don't know if anything is really independent or they are not related between each other. We have really no information about that. So when we deal with bytes, we have absolutely no idea what we are doing, basically. So what we want to do at this stage is that we have a better storage layout, but we need to find a way to store information in the smart contract in a bit more in a way that it's more organized first. Also, that is more understandable. That the bytes it's for the contract, and for us and for interfaces, we can have a way to communicate the contract storages in a more plain language. And we also have to have a way that to deal with the data in a unified way, so that everyone knows how to operate on everyone account storage. And the objective is really basically, to go back to the previous example, is how can we achieve moving from this stage, having data keys with raw bytes, to this stage, having data keys that we can read actually. If you look at this example, it's already a bit, if you imagine this is the storage of a contract, it's probably a bit more meaningful, because you can read what the label of each of these boxes. And basically what we need, if you come from a Web2 background and if you have dealt with databases and in the past, you know that when you deal with data, you have to find a model. You have to create a model you need to find a way to model the data so that you can basically represent it and interpret it and operate on it. You know how to operate on it. And to do that, what we do is that we create what we call a schema. And the schema is going to be a definition of an entry in the smart contract storage. So let's look at an example. Here we have these labels. We could represent these entries in the smart contract storage like that, with a schema like that. So we can see here that this box corresponds to my profile. We can see that the raw data key, this is the key for the smart contract, is this byte32 value. And we can see more information here. We have already a bit more information on how we can deal with it. We can see that it's mentioning an URL, it's a string. Here we can see that it's an address. So we already have more details about how to deal with the data inside these entries. So let's go through. I'm going to try to go through a schema. Very step by step to illustrate and to make you understand what each of these values in the schema mean. So we start with the raw data key for the contract. This is basically the data key that we can use to get the data in the ERC75Y storage. You just go into the contract storage, you do get data, you pass this data key, you will get the value back. This is the language for the smart contract understand. The smart contract will understand the raw bytes for the data key. And this is the name of the data key. Here, this data key the name describe what this data key, this entry in the contract storage represent. And then we have what we call a key type. So the key type defines how the entry in the contract storage should be treated. If, for instance, if it's just a simple key, or if it's an array, meaning that inside this data key there's multiple values, or if it's a mapping, or in the future it could be much more. Then we have a value type. That's how we should decode and encode the data. How we should basically use it. What's its actual type? And then we have a value content. This is more for interpreting it. How we should interpret that. So if we have, for instance, here a string, we don't necessarily know if it's we don't know if my profile is actually the description of my profile, or if it's like an actual file, or if it's something else. And here, in this case, we say my profile is an URL. It's an URL. So this could be a link to my profile page, for instance. So what we obtain with LSP2 is that we obtain a schema to define each data key in the ERC75Y contract storage. So, and this schema is going to help us to first describe the data, second to categorize it, see if there are some entries in the contract storage that relate to each other. It's going to mainly help us to know how to encode and decode the data. But really, most importantly, what we can do with LSP2 is really that we can then create default data keys that every contract account can use. As an example, let's imagine that every one of us in this workshop, we have a profile. If we want to know if we want to get each other profile information, we can basically query the data key my profile into each other universal profile. And so this way we have a very standard and human readable and easy way to query each other information. So we can create default data keys that are universal for everyone, and this is how we help basically. This is how we help everyone to interact between each other on the network. And so this is an example of a very large schema. It's actually the schema, the set of entries in a universal profile. So you can see here that we have this different set of data keys that are basically, we can give an analogy as these boxes. And once we obtain a schema, once we have this different set of entries, what happens is that we can then describe the storage of a smart contract in a much more formal language, like really in plain English. We can say a universal profile has entries like the profile details, the assets. I don't know if you can see here, but the asset that it has issued, the asset it has received, and we will see in a few slides with Yamen the contract address, which is its universal receiver delegate. So we have a model for the contract storage. So LSP2 is really an important standard at LUKSO. It's really what really enables us to really standardize how we read and write and we communicate between each other contract storage. And once we do that, what we obtain is that we have a very clean and organized contract storage. Instead of having raw bytes, we have like an intermediate layer, a schema that enables us to really put a picture into the contract storage. So you can see here you can imagine that each of these boxes, the colors represent the topics, that means that they relate to each other, and basically it's then easy to query and to read and write into the contract storage. So what we should learn from LSP2, in summary, what we have to learn is that the storage of a smart contract, everything is raw bytes. It's very difficult for us as humans and for interface to read and operate on. And with LSP2, we have a schema that helps us to have an intermediate representation of a contract storage so that it's easier to read, to parse, and to operate on. And so then we can use it to know how to encode, decode, and to interpret the information stored in it. And if you want to read more about LSP2, you can basically look at drlukso.tech at the LSP2 JSON schema page, or if you want to go into more detail, you can go into the LIP repository and see all the different key type and entries inside that are available in LSP2. And now I'm going to leave it to Yamen to go over the next standard, LSP1, and to explain which problem it solves and what it enables to do. Yamen, it's all yours.
Thanks, John, for this great explanation of LSP2. So we're going to talk about LSP1. So first we explained the problem of externally owned accounts and identity. And now we're going to explain the problem that we have currently in the blockchain space, and it's about the smart contract interaction. So I will directly start with an example. So this is an example that I found online on LinkedIn. And it's basically someone who created a token on the Ethereum mainnet, and every address on the Ethereum mainnet now own 100 DETs of token. So if we take this address and we paste it on MetaMask, you will see that we own 100 DETs. So it's really a dummy example, and it may not be 100% on point, but it really serves the idea of not being aware of token transfer, not being aware of the token we receive. And this is done by design of the token and NFT contract. So the ERC20 token contract act like a registry contract. It just track the balance of each address of how much he owned this specific token. So let's say you as a sender want to transfer a token to someone, you will call the transfer function on the ERC20 token contract, and this contract will just decrease the balance, will just decrease your balance and increase the balance of the recipient. And the recipient will stay completely outside this interaction. It's the same for ERC721. It's just a registry contract that tracks the ownership of each token ID. So as a sender, you will call the transfer function, and this contract will just remove the ownership from your address of this specific token ID and pass it to the recipient. And still the recipient is completely outside this interaction. So first, the recipient is outside this interaction because first, it's an EOA, it's an external owned account. And second, if it's a smart contract, there is no standard and unified function that all smart contract implement, and we can call it to notify. And why I said unified, because I know someone will get to me and tell me that you can be aware of token of NFT that you receive by implementing the on ERC721 received function. And I will say you're completely right. You're 100% right. But now if I need to be able to receive ERC 1155 NFTs, I will need to also implement this function on ERC 1155 received. And if I want to be able to receive ERC 777 tokens, I will need to implement the tokens received. And if I want to be able to receive ERC 223 tokens, I will need to implement another function. So if I want my smart contract to receive different type of tokens and NFT, I will end up implementing 5 to 10 functions. And each function is different. It has a different name, have different parameter, and it will have a different logic. And if we came up later, like in the future, with a standard called ERC 6700 related to NFT, we will need to implement this function on ERC 6700 token received. And I will not be able to receive this token because my smart contract is already deployed on the network. I cannot add more functions. So that's why we need a unified function that all smart contract can call to notify you not just about token transfer, anything. And in this way, if we come up with a standard later in the future, it can also notify this function that we already have. And this is why we came up with LSP1 Universal Receiver Standard. And basically, we just standardize a function that all smart contract can implement. And it's just about notifying. So if you're an external owned account or smart contract, you can call this function with whatever data you want, and it will emit an event to the network with the data passed to it. So now you can hear the events from your smart contract to know what you have been informed about. So a good example would be the token transfer, since it's the mostly used in the space. So let's say Alice wants to transfer a token to Bob. It will call the transfer function as well as updating the balance in the token contract. The token contract will inform the sender and also inform the recipient by calling the universal receiver function here and here. So in this way, we can be notified about token transfer, and it's, I repeat, it's not just related to tokens. You can notify any smart contract about anything. And we will go through the LSP1 Universal Receiver Delegate. And it's basically just a contract that you can put whatever logic you want inside it, and you will deploy it and take this address, take the address of the Universal Receiver Delegate. You will link it to the Universal Receiver function inside your smart contract. And now, when someone's called the Universal Receiver function, either it's an EOA or a smart contract, the call will be directly forwarded to the universal receiver delegate, and this custom logic here will be run in the same transaction. So we're going to also take an example of a token transfer. Alice wants to transfer a token to Bob. The token contract will notify both the sender and the recipient. But here we have Bob implementing a universal receiver delegate. So this universal receiver delegate is attached to the universal receiver. So all of the logic written inside this contract will be run in the same transaction. So Bob could have a logic where he can decide to revert on all token received. In this way, this token transfer will not go through. He could have a logic where he can accept only verified tokens. And in this way, the universal receiver delegate will read from a registry contract of verified tokens and only pick the tokens verified. It will only accept the tokens verified. He can even go like more complex with a more complex logic where the universal receiver delegate can interact with a decentralized exchange to automatically sell the tokens that are received. So really the possibilities are endless. And I say again, it's not related to just tokens. You could have a logic where an externally owned account will call the universal receiver function with some native coin, with some LUKS in our case. And you can have a logic inside the universal receiver delegate saying if the amount is less than 3 LUKS, do this and this and this. And if the amount is greater than 20 LUKS, do something else. So, and just to mention also that with the universal receiver delegate, you can have multiple logic inside one smart contract. So you could have a logic where you see if you're being notified about a token transfer, then of a fungible token, then directly sell it on decentralized exchange. If it's an NFT if you received an NFT, then directly list it on a decentralized NFT marketplace. And if it's a specific token, just interact with a staking contract and stake it there. So you could have all of these inside one smart contract and just operate on if statement. So as a summary for the LSP universal receiver, with this standard, we can be notified about the incoming and outgoing transaction. And we can, with the universal receiver delegate, react on this information with upgradable logic. So we can have a universal receiver delegate that do certain things. And if we didn't like it, we can change it like after 1 day, 1 month, 1 year, we can always change it. So to know more details about this standard, you can read the specs in the LIP repository. And if you want a high-level overview, you can go to docs.luxo.tech to the universal receiver page and the universal receiver delegate page. And so now we will go through LSP0 ERC725 account. So we explained LSP1 universal receiver, we explained ERC725Y, we explained ERC725X. So all of these components that we already explained form what we call the LSP0 ERC725 account, with the ERC165, which is used for interface detection, and ERC12721, which is for signature validation. So this account, this ERC725 account, should be used instead of the externally owned account to operate on the blockchain, like not for control, just to operate. And since we have this ERC725 account implementing ERC725Y, this means that we can attach any information to it. So now we can attach our name, a link to a profile image, or a description. And this we could do the following with the LSP3 universal profile metadata. And I'll let Jean explain the rest of the standard. To you, Jean.
Okay, thanks a lot, Yemen. So now that we have seen the main standards and how they can form an LSP0, what we call an ERC725 account, we're going to see now a bit more about universal profile and what a universal profile as a standard is exactly. So the motivation behind LSP3 is that smart contract-based account, they can be more than just accounts to store assets and transfer assets. We can basically use this account to also customize them, to give them a bit more appearance, like giving them what we call a look and really a face. And the problem that what this helps us to do is that with a standard like LSP3, we can represent all universal profile in the same way, and then they can become completely verifiable publicly on the blockchain. How we do that is that we do that using the same principle that we use with LSP2. We create a metadata standard, meaning we define two standard data keys that represent a universal profile. And these are the two data keys. The first one that you can see here is what we call supported standard, and it's a key that if you query it, it enables to tell us if the account is a universal profile or not. The second data key is a data key where we can add that can help us to add information to our universal profile. So let's go through each data key a bit in more detail. So as Yaman explained, we have this ERC75 account on the contract, what we call an LSP0, and we have this contract that has these multiple functionalities from ERC75X, Y to also LSP1, and also this standard interface detection with ERC165, and with ERC1271 to enable us to verify signature. But how do we know if this account is actually used to represent a universal profile? The way we do that is basically to check the contract storage. We check if in the contract storage there is this data key set. So what we're going to do is that we're going to use getData, the standard function from ERC75Y, and we're going to pass on this data key. And we're going to query the contract storage. If we don't get anything back, if we don't get this value back, that means that this account, this ERC75 account, it's not a universal profile. But if we get a value back, then we can deduct that this contract is actually a universal profile. So this data key is it's a key really to confirm that the account is an this ERC75 account is a universal profile. And then this way, we can have a universal profile for multiple users and entity, and we're going to see that a universal profile can be used to represent many different things. Now let's look at the second data key. As I said, a universal profile, they can have their own metadata. They can have their own, their more detailed information to describe them. And this information can be found under this data key, LSP3 profile. So how we fetch the profile information? We do exactly the same thing. We basically do getData in the contract storage using this data key, and what we get back is what we call a JSON URL as per the LSP2 standard. And this is basically a link to a JSON file that will contain all the profile information. And this JSON URL, this file can be hosted literally in any place that you want. You can specify that inside the actual encoded value. It can be stored, for instance, in the decentralized file storage like IPFS. It can be stored on a private server. It can be stored on the cloud. It can be stored, for instance, on Google Drive, on Dropbox. It's really up to you or around about where you store this JSON file. So what does this JSON file look like? It looks roughly like this. So you can see we have many entries, including the name, the description, And all of these entries, they represent to something in particular. You can add tags to your universal profile. You can add links to your social media pages. You can add more description, and you will see you can also add references. You can specify also different. Here you can see for profile image and background image. You can see that it's an array. So that means that you can specify even different the same image in different size, so that interfaces can fetch the right size for optimization on the interface on the front end. So you can really store a lot of information in this JSON file. So we have this standard structure, but you can literally add also as many custom information as you want. And the best way really to get the feeling of a universal profile and to see really what it looks like is to try the universal profile browser extension. And this is really cool. It's very easy to install. I will recommend you to go onto the doc.lukso.tech and to look into the guides. There is a section for the browser extension, and it's really easy to set up. You download the package, you unzip it, you install it into your browser, and then you will be prompted with a page to create your universal profile, and then you can open it the same way that you open your other wallets. You set up a password initially, you open it, and then you have your all your different screen, including the dApps that you are logged in. You have, this is like an example of a screen when you are using your universal profile to interact with another profile. So for instance, this is the screen if I will be transferring one LIX to Yemen. You have this prompt screen. You can also adjust the transaction speed, and there is all. And if you don't even, we will see if you don't even have funds, you can use a relayer to so that the relay service pay for your gas on your behalf up to a certain quota. So yeah, really cool universal profile browser extension, and I highly recommend to use it. And you can see here the JSON file with all the profile details. You can edit them directly in the browser extension here. You can add more details. You can edit your profile picture, your cover picture. You can edit your tag, your biography, and your description. So really, browser extension, it's a very good way to see what a universal profile look like. And there is also another source that if you're curious about what universal profile look like, it's universalprofile.cloud. You will see a lot of different profiles that have been created on the L14 network. And basically all these profiles, the information that you will see from them, like their profile picture, their name, all of this information, all these details, they are fetched from the same JSON file that I've shown you previously. If this JSON file is referenced into the contract storage. So that really enable us to add as many LSP3 is really a way to give really a persona and a face to an account-based contract and really customize it. And thanks to LSP3, what can we do? We can use a universal profile to represent a lot of different things. It doesn't necessarily have to be your universal profile. It can be your profile to interact across dApps and use the browser extension, but it can also be your profile for a creator on the platform. So for instance, if you are an artist and you create digital art, or if you create vlog videos, you want to, you are a content creator, so you can have your own, your own name, or you could even have your own brand as well. You could use the universal profile to represent your own brand. And for instance, one of the popular brands that we know at LUKSO is the Dematerialize. You can use that to represent such brand. And you can really, if you can think really very far, you can even use a universal profile to represent a character in a video game that you are playing. Your main player or your main character. And another really different use case is using a universal profile to represent something more like really different, like an organization, like a decentralized organization that can be controlled by multiple stakeholders, like a multi-sig. And this organization can also have a form of identity. With LSP3, you can attach as much detail as you want into this JSON file to really describe what is the DAO, what's the motive behind this decentralized organization, and basically what's the reason they exist. And this really enables us to customize an account-based contract as much as we want. So what you should learn in summary from a universal profile is that universal profile, it's as its bare bone, it's really the combination of LSP0, what we call an ERC725 account, and LSP3, which is the metadata to represent a universal profile. And an LSP3 profile, it's a standard that gives a face and like a persona to an ERC725 account, and you can use the standard to represent multiple things, as I say, like a profile, a content creator, a character, or like more a decentralized organization. And if you want to learn more about the standards, you can also go to the doc in the LSP3 Universal Profile Metadata section. You will get more details about each data keys from the standard. And you can also deep dive into the standard specification on GitHub. So now let's recap a bit where we are with the LUKSO standards. So as we said, what we are building with at LUKSO is really building blocks. So we want to represent standards as building blocks, like Lego pieces that you can use to create your own architecture, your own dApps, and really make your own creation. So I'm gonna use an analogy of Lego blocks to map the whole architecture of what a whole universal profile is. So first, as we said, it's an universal profile is an ERC725 account. It's a main contract that has different interfaces in it that you can use to interact with other addresses and accounts on the network. And basically, this contract has storage. It has a storage that uses LSP2, the schema. So if you think of LSP2, it's really like a plate, a Lego plate. So in Lego, there is two main Lego bricks. There is like bricks, and there is plates. And LSP2, really, if we would represent it in Lego pieces, it's like a big plate with a lot of dots where you can plug metadata into it. Imagine that every single pin here on the plate, it's an entry to add some metadata. So what we can do is that we can take a schema of multiple keys, and we can add these keys into the grid, into the plate. So let's continue really building from the ground up the LUKSO standards. So we have a universal profile where we add some schema to represent the contract storage so that it's easier to use. And now let's add some metadata to it. Let's really plug some dots, like some metadata. And we're going to plug the two metadata key for LSP3. As we have described, the first metadata key to say this contract, it's a universal profile. And the second metadata key, this is a link to the JSON file that describes the universal profile. So really, we plug default metadata entries into the contract storage to really represent the contract. And now as we know, we also have in the ERC725 account, there is also another feature that Yaman explained is the universal receiver. And the universal receiver, it's as Yaman described, it's an entry function that enables us to receive any arbitrary information. And you can really use this function for about anything that you can imagine. So like Yaman was saying, things like receiving tokens, or only some for instance a specific token, and then add them into your contract, or you can also do things like being notified for a certain type of events. You could, for instance, use the universal receiver. Yaman was also explaining, to be notified when you receive just native tokens. And a good example for that is, let's imagine you are a content creator on the platform, and you want to receive some royalty payment. You have participated in making a movie, and you have rights for royalties. You could receive monthly payment of your royalties by just having the DApp and the protocol that call this universal receiver function and passing what we will see we call a hook to just notify you have received some royalty payment, and this will be submitted as an event. So we have this entry function, and as we saw, we also have the ability to delegate more custom logic to another contract. And how we do that, how we delegate the universal receiver function to another contract to do more complex thing, it's still the same principle. It's very easy. You just go into your contract storage, and in the default metadata key, you say in the data, in my contract storage, under the data key LSP1 universal receiver delegate, I'm going to specify an address. And this address is going to be the address of my universal receiver delegate contract. And this will enable us, as well as notifying us about incoming transaction, it will enable us to delegate more for the functionality to this contract and to do more complex logic. So really, it's all about that. It's all about adding entries into your contract storage. And you can see here, it's with LSP2, it really makes sense. It's just plain human readable data keys. We understand what this referred to. And when we put color, and we use this analogy of Lego bricks, it's just easier to understand the whole architecture of a universal profile. So as we said, we have this universal receiver delegate contract, and then thanks to by just adding a metadata key into the contract storage, then we have creating a link from your account contract to another contract to delegate more functionality. As Yaman explained, what is really easy is that if you want to upgrade your universal receiver delegate, the only thing that you need to do is that you need to go into you create a new universal receiver delegate, you deploy it on the network, you go into your contract storage, and you change this entry from the version 1 of your universal receiver delegate to the version 2 of your universal receiver delegate. That's all you have to do. And then the contract will delegate the functionality to this new universal receiver delegate. So it's all about really editing for most of the things for contract storage. And so now I'm gonna go through another standard, which is the LSP6 key manager. So we have seen now how the universal profile operates and how it functions, and the really great feature that LSP1 adds to it about the fact of being notified about a transaction. And we also see that on top of being able to add as much information as we want, we can really execute very easily. And one also extra standard that we can add to the universal profile is we're going to see the key manager. So to understand the key manager, we have to really go back to our universal profile. When you have an ERC725 account, I think we all know it. If everyone who has used blockchain and externally on the account, we all know that when you have an account on the blockchain and you have funds in it, like you have a lot of responsibility. Everything, you have to be very careful of what you are doing. And the same apply to an ERC725 account. Why? Because let's have a look at this picture. This is the two main function really of your universal profile. it's the execute function from ERC75X and the set data function from ERC75Y. So the function that Yaman was explaining to interact with the rest of the network, like things like transferring just native tokens or interacting with other addresses, and set data to edit data into your contract storage. But we can see from the Solidity code that these functions are marked as only owner. And this is basically the same idea, is that with great power comes great responsibility. If you have an externally owner, you basically have an externally owned account linked to the contract, but only the owner of this contract can use this function. So when you don't have a key manager, only the owner of the externally owned account can interact with this function. So in this case, it's Bob. But now let's imagine this scenario. There is a problem with ownership of a contract, with the ownable pattern, is that let's imagine that Bob here is the only owner. So let's imagine this account in the screen. Bob is an externally owned account. It's the owner of a UP. Bob, to be able to interact with the network, to send links, to send native links to other addresses, or to set data and update his profile for the different dApps that it's connected to, it has to do everything by himself, because he has to call execute, it has to call set data, and only the contract owner can do that. So Bob has to basically do everything. But how about if Bob makes a mistake, like for instance, do some mistake in the contract storage, or how about if it's actually loses its private key? Then Bob cannot even access anymore his universal profile. And this is basically the problem, that when you have a main owner, you have to do everything on your own. And if you do any mistake with an ownable contract, you basically are under great risk. So what we say is that Bob is an overpowered owner, because Bob has a lot of things to do. He has a lot of responsibility, and ideally, what would be easier is that if it's Bob would be able to what we call segregate duties, meaning like if he can delegate some task to dApps that he's connected to, and allow them to do these tasks on its behalf, while still keeping really control under its account. But so how can we really achieve that? How can we make the life easier for Bob as the account owner, while still leaving Bob a great level of control? And what we do that through a contract and the standard based on the standard that we call a key manager. And what happened is the following. When the key manager is a contract that you deploy on the network, and that is going to become the owner of the ERC75 account. And this, when you have a key manager as a contract owner, you are going to be able to have multiple addresses interacting with your account, so that you don't have to do everything on your own as a contract owner, but you're going to be able to do that also while keeping a great level of control. So let's really recap. The problem is that the universal profile is only controlled by its owner, and if the owner has to do everything, it's really limited on terms of usability. It's like there is no interaction flow really that can happen. There is only the contract can receive token, but for the main functionality, like setting data and interacting with other addresses, only the owner can do it. And by using a key manager, what we now enable to do is that we use what we call a permission system. We give permission to third-party addresses. So these addresses can literally represent anything. Can be a protocol, can be a dApp, can be a device that has its private key in it, can be your friends that you trust, but can be any other third party that you will have your universal profile connected to. And we're going to give them some permission so that we're going to allow them to interact with our universal profile on our behalf, but we're going to restrict them to only do specific action. Let's look at this. Let's illustrate that with this screen. We have, for instance, Bob, who is still the main contract owner, and we have these over externally on the account, like Alice and Carol. And what we're going to do is we're going to say, okay, Alice, I'm going to allow you to set data on my universal profile. Data maybe that might be relevant to Alice. And Carol, we're going to allow Carol to transfer value to over contracts. And by doing so, we give some new, basically, we allow more interaction flow in our universal profile. We basically delegate some tasks to other addresses so that we don't have to do everything on our own. But we also keep control because we just give specific permissions. So for instance, Alice, so how the key manager is going to work is going to be as follows. Alice now, if Alice wants to interact with my universal profile, it's going to have to interact with the key manager. And the key manager is going to read Alice is going to provide what we call a payload. It's going to be basically, it's going to be the action that Alice wants to do on the universal profile. So for instance, let's imagine Alice wants to set data on my profile. And the key manager is going to read what the action is. It's going to look at the permission. It's going to read into the contract storage of the universal profile of Bob if Alice has some permission set. And if Alice has the permission for the action that it's trying to do, it's going to allow the call. So if Alice is trying to set data, in this case, and Alice has the permission to set data, then it's going to forward the transaction to the ERC725 account. What happened really under the hood is really the function call in the contract, which is API encoded. The raw payload is provided to the key manager, and the key manager is just going to decode really under the hood, chunk by chunk, all of the bytes. And then Carol is going to, for counter example, let's imagine Carol tries also to set data. But if Carol doesn't have this permission, because Carol is just allowed to call on transfer value, then the key manager is going to reject the execution. So it's going to stop at some, it's going to say, okay, Carol is not allowed to set data on the universal profile because Carol doesn't have a permission, and it's going to revert. And the idea also of that is that first, these addresses that interact with the universal profile via the key manager, they can be really anything. It can be an externally owned account. It can be any other smart contract. It can be another universal profile. It can be a DeFi protocol. It can be a DApp. It can be really anything. Any application dApps that want to interact with the universal profile is going to go through the key manager. And the second point is that all the permissions of these addresses are stored under the ERC725 account. That means that if you upgrade to a new key manager, or if you decide to not have a key manager anymore, or if you want to have a better version of a key manager, so like upgrading to key manager version 2, then you will not even have to reset all the permission all over again, because all the permission are stored in the actual ERC725 account. So that's a great feature that the key manager allows. So what the key manager really can do, if you think about it, depending on the perspective, it can restrict, or it can authorize, or it can allow really interaction from multiple sources. And if you can see from the screen, the key manager allow other addresses to either set data to call execute, meaning doing over interaction with the rest of the network, or to do some upgrade mechanism, like transferring ownership of the account to another contract, whether this contract is key manager version 2, or an externally owned account, or any other smart contract. So now we saw that the key manager has what enables us to do, but let's see now the basic permissions that we can give to other addresses to interact with our universal profile. These are the permissions. They are listed to give like an overview from the top to the bottom, to the ones that are really the most sensitive to the ones that are a bit less sensitive. This is like just a bit of a more simplistic overview, but really it's you can consider that anything related to changing ownership of a contract or changing permission, it's quite sensitive. Delegate call, I think we all know it's very, very sensitive. We have it disabled for now, but that's the order of that we can consider them. And we can really do the same that we did for the LSP. We can basically segment the permission in different in 4 different categories. So we have the permission change owner, which relates to managing contract ownership. We have the permission related to your contract storage, so setting data, meaning editing information on your universal profile, or giving permission to or managing permission of over addresses. So either granting permission to new controller addresses or changing the permission of addresses that already have some permission. And then we have the permission related to interacting the rest of the network. So you can give permission to addresses to do call. Call, for instance, is a permission that you will use to allow an address to interact, to use your universal profile to interact with another contract. Then you have static call, delegate call. Then we have deploy. This gives you allow you to use the universal profile to create another contract, either via create or create2, and then transfer value, meaning we allow to an address to transfer value from our universal profile on our behalf. So that's the 4 main category of the permissions in the key manager. But we also have more fine-grained permissions in the key manager. Apart from these are the permissions, meaning these are what we can allow addresses and third parties and dApps and protocols to do on our behalf. But we can also give them have a even more fine-grained control by restricting even more to some specific subset. And we can differentiate them into 2 categories. We can have fine-grained control over setting data. For instance, I could allow Yamen to edit my universal profile information, but I could allow him to only edit a specific set of data keys. And then we have fine-grained control over interacting with over addresses. We can allow dApps protocols to use or to call our universal profile so that they can interact with other addresses on our behalf, but we can restrict to which address we allow them to call, or which standard, for instance, which type of contract they can call. So let's go through some basic example really of this fine-grained permission to really get a bit more of a picture of this more fine-grained control. Let's start with allow the RC75Y key. And best example is the best way is same to use an analogy, really with a picture of imagining our universal profile connected to multiple applications. So we have our universal profile, and we have on the network different dApps with some smart contract behind them. We have what we call, let's imagine a music dApp, we have a game dApp, and we have a DeFi protocol in the network. And we have our universal profile connected to these dApps. And as we said, we want to allow this dApp to use our universal profile so that we don't to interact directly with our UP, so that we don't have to do everything by ourselves. So we're going to allow this dApp to set data, but we're going to restrict this application to only a specific set of entries into our contract storage. So for instance, we want to allow the music dApp to be able to set data. So we give a permission to the music dApp to set data, but we restrict the music dApp to only be allowed to edit the data key, the entry in our contract storage called music dApp data. we only allow this protocol, this tab, to operate on this entry into our contract storage. So this is what we can do with allow ERC725Y keys. We don't want, for instance, to allow the music tab to edit the entry for game tab, the data entry that corresponds to another app or another protocol. That wouldn't really that wouldn't really make sense to allow a tab to edit the information that relates to other tab in our universal profile. Or even more, we don't want, for instance, to allow a protocol to edit or profile information under LSP3 profile. So by doing so, by doing allow ERC725Y data key, what we enable is that we enable to give permission of editing or profile info, so that we don't have to do everything else, but we can really scope what data we allow these protocols and this app to operate on. So that's a very good feature of the allow ERC725Y key in the key manager. And let's go for another example, more around fine-grained control around interaction. As we say, we want, for instance, to allow an address to interact with other addresses, but only to allow it to interact with a specific address. For instance, this caller, we're going to give him access to interact only with this free address. So this caller will be able to call this address, and this other address. So for instance, this could be an externally owned account, a smart contract, or a token contract. So this way, we allow only to interact with a very specific set of contract. And if this caller tries to interact with a contract that has an address that it's not allowed to, then basically the call will fail. And what we can do even more, a very interesting restriction on the key manager is what we call allowed standards. And this is really useful if you want to allow application and addresses to be able to interact with only contract that implements specific interfaces. So let's imagine you want to connect your universal profile to an NFT marketplace, and you want to, or like a decentralized exchange, you want to allow the decentralized exchange to transfer tokens only LSP7 token on your behalf. So you allow this exchange to transfer only tokens that belong to you, but only tokens, not NFTs, for instance. Or you could do the other way around. You could allow an NFT marketplace to transfer NFT but not a token. So that's a great feature to allow application and protocols to use our universal profile to only interact with a specific type of contract. And then one of the final key feature on the key manager is the ability to accept transactions from a relay service. And why is this really important? It's because mainly it's around the fact of being able to onboard people on using universal profile. So when we have a universal profile linked to a key manager, what is really great is that we can either allow the main owner of a universal profile with its private key to interact directly with the UP, so meaning the main controller address, the main externally owned account that is the main controller of this UP. If it has fund, it can interact directly with it, or we can also allow the main controller or any of the address really to craft API code, to craft basically payloads and to submit this payload to relay service. And the relay service, what they're gonna do is that they're gonna pay for the gas. They're gonna pay for the gas and they're gonna forward the transaction of a caller. And how this works is that the main externally owned account is going to basically sign the transaction, and it's gonna submit it to the relay service, and the relay service is gonna submit my transaction. So to give an example, let's say Yaman wants to interact with my universal profile, but he doesn't have any leaks. and Fabian has a relay, operates a relay service. What Yamin is going to do is that it's going to sign the transaction of what he wants to do on my universal profile. It's gonna submit this transaction signed to Fabian's relay service, and since this transaction has been signed by Yamin's private key, it's going to be sure that this comes from Yamin, and then the relay service is going to forward the call to the UP. So the relay service is going to pay for the gas, and what the key manager will do under the hood is that it's going to recover the address of the signer, and it's going to check if the signer of this transaction, here in this case, this will be Yamin, has the right permission to do the operation that he wants to do. So that's really what's really great here with a transaction interaction via relayer, is that now we can differentiate who is the executor of the transaction with who is the actual who is executing the transaction and paying for the gas with who is making the actual request on the universal profile. And this is enabled by the key manager through one function, from one of them function. So now let's summarize the key manager. So it's a lot of feature, as you have seen. And if we can summarize it in 4 main bullet points, we can say that an ERC725 account, when it's controlled only by its owner, it's quite limiting. You cannot do much apart from being the only address to be allowed to interact with your UP. And with the key manager, what we enable to do is that we enable third parties to interact with our UP, but we still keep controls over it. We keep control by setting the permissions, and we set this permission in the storage of the universal profile. And if we upgrade to a new key manager, we don't have to reset all these permissions because the permissions are stored in the universal profile. And with the key manager, what we can do as well is that we can interact directly via UP, or we can interact via the relayer. So the key manager really offers you this ability to do gasless transaction. And if you want more details about the key manager, you can go on dr.LUKSO.tech, where you will find more figures and more explanation with more diagrams about each permission. And you will also learn how different permissions can be combined, and how all the details about the fine-grained permission and the details about transaction via universal profile of via relayer. And you can also go into the standard specification. And let's go back to our Lego blocks to finish building the architecture of our universal profile. We have this key manager. It's a standalone contract. We deploy on the network, really. And we have this same subset of keys. And it's the same. They have their own schema. The schema, you can find it on the docs as well. We have a key to list all the addresses that have permission. So if you query this key, you will be able to basically to retrieve all the addresses that have some permission set on the universal profile. Then you have the key for the main permissions, meaning you will put the address in this field, and you will be able to retrieve the permission of this address, what this address is allowed to do in your universal profile. And then you have keys for more fine-grained control, like the allowed address, the allowed function, the allowed standards, and the allowed ERC725Y keys. So it's the same concept. You add metadata key into your contract storage, you plug more entries into your contract storage, and it's the same. The key manager, when it interacts with you, when you try to interact with your UP, the key manager, what it does is that it's linked to your profile. It's going to read the permission of the addresses that are making the call. But as we said, despite the fact that we have more fine-grained control, we have more permission, we also need some form of mechanism to be able to retrograde, or if we lose some form of permission. And how we can do that is we will see later with a social recovery contract. And let's wrap up a bit the architecture of the universal profile. If we look at the Lego blocks, we can see that these actually represent the whole universal profile architecture. Universal profile architecture is that it's a profile that has a face. You can add image and description and tags. It has more control and security. You can connect things like apps, devices. It also supports gatless transaction, and it can react on incoming assets and transactions. Like for instance, you can use the universal receiver delegate to move your assets that you receive into vaults, or you can keep track into your contract storage of assets that you have received. And this is basically if you create the universal profile using the browser extension or the LSP factory that you will see in the next upcoming workshop next week. When you create a UP, this is the whole architecture that you have. Everything is set up for you, and you don't have anything to do. The whole setup, the whole standard that we have defined, it's already made for you. So we have in the center the main account contract or universal profile, which is an actual ERC75 account. And we call it a universal profile. Why? Because it has the metadata entry into the contract storage. Then we have a universal receiver delegate on the right. It's another contract linked to your account that enables you to inform and to react on specific assets that you receive, or on any form of information that you want to be notified about. And then you have a key manager, which is the main controller of your account, that enables you to give more fine-grained permission and control and allow third-party transaction. And same, the permission of your universal profile are stored in your contract storage. So this is the architecture that we use at LUKSO with our current standard implementation. So if you download our NPM package, you will basically get this standard architecture, the contract linked together in this way. But really, in reality, what we want to emphasize is that each contract, each standard can work really completely independently on its own. You can really use every single standard to create your own architecture. And for example, to illustrate, you can use a universal profile without a key manager. You can have a UP controlled by it in the OA. You will have less feature than without, but it's a choice. You can absolutely do that. Or you can have another example. You can use a key manager to control something else than a universal profile. Or another example is that you can link a universal receiver delegate to something else than a universal profile. For instance, you could link a universal receiver delegate to a decentralized exchange, to an NFT marketplace, or to your dApps, and to really to a smart contract behind your main dApp. And really, you can use these standards on their own independently. You can use our own architecture, but you can also use them on their own. And now I'm going to leave it to Yamen to go back into this this problem that we have, this problem we could have despite the key manager around losing access to the key, and with LSP11 social recovery. Yamen, I'll let you the microphone.
Thanks, John, for this amazing and detailed introduction to the LSP6 and LSP3. So we're gonna go through LSP11 basic social recovery standards, and I will give this example. So as John said, the ERC725 account can be controlled by several devices if we use it with a combination with the LSP6. So we can have our device, we can have our friend, another person controlling our ERC725 account with different permissions. But if these controllers are externally owned account, that means that still their address is controlled by a private key. And if this private key is lost or leaked, we will lose access to our ERC725 account. So that's why it makes sense to have, aside from the other controllers, to have a social recovery contract that is not owned by anyone, and it has the permission to add another addresses to control your ERC725 account based on some mechanism that is written inside the contract. So this contract, so as a setup, this contract will need to have a permission inside the ERC725 account to add other addresses to control the ERC725 account. So how we can set this social recovery is by deploying the contract. Once we deploy this contract, it's linked to the ERC725 account. And the first step is starting adding guardians. So we can add any number of guardians we want. And these guardians could be devices you own, they could be your friends and family, or even they could be a service that you can subscribe for, and it can vote to recover your account based on some face recognition. So after setting the guardians, we should set the threshold. So the threshold could be 2 guardians, 4 guardians, any number that we want. And the threshold is the minimum number needed, minimum number of votes needed in order to recover your accounts. And why it's advised to have a threshold number lower than the guardian number, because you can have some guardians that lost access to their account, or when you want to recover your account, they are not available. So that's why it's advised to have a threshold lower than the guardian's number. And now the third step is to set a hash. So why we have a hash? Because we don't want to rely only on guardians to recover your account, because maybe some of the guardians will act maliciously and they will try to take over your ERC725 account if there's no secret hash, and maybe they will get hacked. So in order to avoid this takeover, in order to avoid taking over your account, that's why there should be a secret hash that you only should know. And after each guardian voting for your address, you will provide this secret. You will provide a plain secret that form this secret hash, and you will have access. So how it's done? First, the guardians will start voting for an address. So you could have 4 guardians voting for this person, 1 guardian voting for this other person, and you could have guardians that don't vote. So since the threshold is 4 guardians and this person has 4 votes, now it can interact with the social recovery contract, and he should provide the plain secret that form the hash that is stored inside the contract. And if this plain secret is right, if this plain secret form this hash, then he will be added as a controller to the ERC725 account, and he will be given all the permissions. And if the plain secret didn't produce this secret hash, the guardians should, they can still vote to another person. So they will start another recover process ID and vote to another person. And just to mention that this social recovery contract is reusable. So now we have this person added, we finished the social recovery, but this contract, we can use this contract to add more person if we lost access to, if we re-lost access to these 3 devices. And how it's done, how we can make this social recovery contract reusable. When this person, before completing the recover process, when this person will provide the plain secret that provide the plain secret that produce this hash, in the same transaction, he will provide a new hash that will be set, that will be updated in the contract. In this way, we can make the social recovery contract reusable. So to summarize, the LSP11 social recovery, it's a contract that recover access to ERC725 contracts through the LSP6 scheme manager. So it's not just ERC725 accounts, just any ERC725 contract that's controlled by LSP6. We can have a secret hash to have more secure recovery, and it's a reusable contract for next social recovery processes. So as Fabian mentioned yesterday, it's still a draft standard. So we have a pull request in this GitHub repository in the LIP. And we have a contract implementation. The contract implementation is fully working, but we may do some cleanups and some few minor changing. But we have a clear vision of how this standard should be done in the way that I already explained to you. So if it will change, we will just change a few and minor stuff. And now we reached the conclusion. I guess, Jean, do you want to take over?
Yeah, sure. We have, as Yamin said, we reach the end of this first workshop, and if there's something really that you can you can grab from this main part one presentation is that LUKSO, believe LSPs on LUKSO, they are the standard building blocks of the LUKSO ecosystem. You can use them even them as a standalone, but really when they are used together in concert with the whole architecture that we have described, they really provide a really better user experience, and they offer really a different way to interact on the blockchain. And so then what should come next is what are you going to do, and how are you going to use these building blocks to build in this hackathon? And it's up to you and to your own creativity. Really, you can use them as I said, standalone or in combination with our own architecture, and to create a really amazing things. And if you want more, if you want to go more in details and more in depth, you can go into the docs on doc.luxo.tech, or you can go, if you are really wanted to go into the standard specification, you can go into the LSP repository. And also, I would highly recommend to really to get if you want to go from get the full background to each of the standards, to read this three-part series from Felix, and he will be presenting during the DApps workshop next week, and to really read all of these articles, because they are really great and they really provide a very good insight on the whole LUKSO ecosystem and all of the standards. And if you want to know more about the next LSPs, because we have more coming, we have more standards, and if you want to learn the other standards, we invite you to join tomorrow for the part 2 of this workshop series, and to really learn the next LSP standards, which will be more oriented towards digital assets, tokens, and NFTs, and Vault standard. So we hope you find this presentation in this workshop useful. We all thank you very much for being here, for attending, and we are happy to welcome any questions now.
All right, thank you both so much for all this in-depth information that you shared throughout this session. I see that there's a few questions in the Q&A, so let's just go over those. Let's see. All right. Let me see if I can show these on stage. Okay. If I understand this correctly, once these standards are on the mainnet, they won't be able to be changed. Is that correct? Will LUKSO be able to add new LSPs in the future if new use cases are needed?
Yeah, let me answer this. So these are smart contract standards, right, that are proposals, and they're even in draft. So, I mean, we have basically been finalizing them all pretty much, but I mean, some will be finalized later. So with a smart contract standard, there is no enforcing, right? People have to pick and choose to use them, right? You can also deploy an ERC20, deploy whatever other smart contracts you want on LUKSO mainnet. So nothing is, fixed in that sense. Though the basic smart contracts, right, universal profiles, schema, all of these things in the current form, we see them as more or less final. obviously, if there's issues coming up, that are really relevant and we need to somehow improve them or change some small things to make them better, that obviously will happen, if that's needed. But basically, like nothing is final, right? There can be also a new version of that standard, or like a separate standard that's like an upgraded version of a universal profile and things like this. So this will evolve over time. Anybody can actually propose LSPs, right? LUKSO standard proposal means just that they are inside the LUKSO ecosystem, right? And this LSP repository, but anybody can propose an LSP. And going forward, we will propose more from the LUKSO side, right? Ideas that we have and things that we think are important, but anybody can come with a proposal. I mean, obviously, it takes time to do these standards discussions. And one of the reasons why we come up with a set of standards is so that we have a basic framework that people can build on that is better than what we have in Ethereum and other places, because there was no process when we started Ethereum. There was not a proper standards process that came actually months later. And there was also not a lot of like thinking to, really making these standards work in concert. So now that we have the ability to actually start a new network and really think the basics through and redo them and do them the right way, and adding the identity piece that's missing, then we can have a better foundation on which people can build. Obviously, later anybody can propose a standard, right? And these standards will evolve, and it's a discussion, because even if you propose a standard, if nobody adopts it, like, it's irrelevant. So it's the same process like in Ethereum, basically, right? Except that we do this in a new space, the LSP repository, where we can basically change and improve on the old and make it a cleaner, basically, and a more quiet space that can improve on new building blocks. I hope that answers the questions.
All right. Dave asks, who will pay for account creation along LUKSO steps, covering the guest cost to do so? As far as I understand, there is currently a cost to create the account, including storing the profile image in IPFS, correct?
So that's a really good question. So first off, you can pay always yourself, right? If you have LUKS and you put them on your controller keys, you can make transactions like on any EVM blockchain or any actual blockchain network. So you can always pay for your own transactions. But obviously, we want to have a user experience where people have an easier onboarding, right? And because you start ideally with a smart contract-based account, not just a key, somebody needs to deploy the smart contract-based account. So we will subsidize this for early users, because we will run basically a public relay service that will give you a certain amount of gas per month, and you have to authenticate in some form, so that it's one human, a few profiles, and the idea is obviously that we have a competitive landscape of transaction relay services in the future that see this as a for-profit business to attract users. For example, with a freemium model, so that they use their relay service. The same like you use, telecom or different kind of mobile phone providers that pay for your mobile phone data, and users will have the ability to sign up, get a free profile, maybe get half a month free or a month free of free gas, and then they have to pay. And that's also enough time so that they realize why a blockchain-based account makes sense and why they need it. So it requires this economy to become a thing, right? And as long as that's not the case, we see there's a need for us, subsidizing, early users, then we will do that. And also IPFS costs. I mean, IPFS is free. Obviously, you can store your profile images wherever you want. Ideally, in the future, you can even pick your own Google Drive or, your home router or whatever, where you store your profile images. So it doesn't matter where it's stored, really, like in terms of your pictures and your descriptions and so on. That's already very dynamic. We just store it on IPFS right now. We will also offer a centralized file store where we can delete your data if you request that. Obviously, on IPFS, that's different. Yeah, that's also something that we will basically provide for the community for some time.
All right. Let's see. Are there plans to build a LUKSO mobile stack so we can use it in native mobile apps and not just responsive web?
Yeah. So we're building a mobile version of the UP extension that basically allows you to basically allows you to control your universal profile on a mobile app, right? And that means you can also log into another mobile app or log into a website on mobile, and this uses Wallet Connect currently. So you would basically press the Wallet Connect button, it opens up, it switches to the Universal Profile mobile application, and you authenticate and you confirm transactions in that Universal Profile mobile application. And then you can literally build any kind of app and still have your control within your Universal Profile mobile application. You can even log into websites this way, Wallet Connect makes it possible.
All right. Next question. On the GitHub for LUKSO, I found some different defenses against reentrancy attacks in 2021 and current. What is the current best practice to use LUKSO defenses? What is the nature of those defenses?
I do not understand that question. So I'm not exactly sure what it means.
Martin, would you like to come on stage and ask that question live? I can bring you on stage.
Or maybe you want to add a new, put in the chat an elaboration, because I don't know what kind of re-entrancy attacks you found, what defenses I don't understand it.
All right. Let's see, we can move on to the next question. And let's see here, how to create a new JSON schema object and how to integrate with the contract.
So basically, the JSON schema object is really just something that you define, right? You say, hey, this is the type of key, this is the name of the key, and that's maybe you can actually leave the questions up when I'm answering the questions, because then it's easier for me to reference that. Because now otherwise I have to find it. Okay. And how to integrate with a contract. So you can basically, the JSON RPC, the JSON schema, sorry, is only there to make it easy for tools like ES75 JS to read, encode, and decode data written in the smart contract. That's what the JSON schema is for. It's like a tool. It's like a helper for tools like ES75 JS or tools in the future, right? If you know how, like in your app, for example, if you know what the key hash is, right? The 32 bytes key, and you know exactly how to decode it, you don't need any of these tools. You don't even need the JSON schema. You can just, hard code the 32 bytes that you're calling and get data, and you know how to decode this. So the JSON schema is a tool and a helper, so that tools like ES75 JS can automatically decode things. So when you propose, for example, a standard in the future that's based on LSP2, and you want to make an elaborate JSON schema, right? Then you can do that, right? You can say there's these 5 keys, they say this and this and this, and they count this and this and this, and you will put your JSON schema on the bottom so that other people can easily interact with, contracts that store their data in that form. That's basically the reason for the JSON ERC75 JSON schema. Sorry.
Okay. Are these smart contracts audited?
They are currently being audited. In fact. So we're currently auditing them already with the second auditor. So that will take a bit of time. If you're a highly skilled smart contract auditor, as a single person, we also would like you to look at it if you really know what you're doing. But we are having some very big audit firms currently looking at smart contracts.
How is LUKSO different from other blockchains? Is it layer 1 or layer 2?
It's a layer 1. It's a blockchain that works like ETH2. So it has a Casper consensus beacon chain that connects to an execution chain that's tightly coupled. Yeah, works like ETH2. It's a layer 1. Proof of stake.
Okay, let's see. What does the default universal receiver implementation?
So the default, that's a very good question. So the default universal receiver function obviously just receives something and fires an event. I think you mean the default universal receiver delegate smart contract. And maybe Yamin, you want to answer this because you actually wrote it.
Yeah, yeah, sure. So it was planned to talk about this tomorrow, but I'm gonna answer briefly. So the universal receiver, our default implementation, will write the received assets, the addresses of the received assets you own inside the smart contract. So inside your profile. So in this way, you don't need a centralized like a service to fetch all the tokens that you own. You will just simply look inside your storage and you will know what different tokens you own, tokens and NFT for sure. We're gonna go in details about this tomorrow through the LSP5 received assets standard.
Okay. Let's see. I see Ian Smith has raised his hand. Let me see if I can bring him on stage here.
And maybe quickly adding to this, basically, we have not standardized the universal receiver delegate behavior. There can be all kinds of implementations and logic that people do. You could have a universal receiver delegate that has a whitelist of token that you can receive and everything else you reject. There could be all kinds of crazy things you do. Currently, it really just stores addresses of tokens you received and also removes them when you have a balance of 0. And this way it gives you a decentralized portfolio. Yeah.
Okay. Thank you. Okay, so Ian, I see you have raised your hand, so I'll go ahead and hand you the mic so you can ask your question. Okay, you can go ahead and speak.
About the reentrancy attacks in the wrong chat, so people copied and pasted for me into the Q&A. Since you have all of these smart contracts that are being deployed, how are those smart contracts that are managing your permissions, managing your assets, managing your keys, how are they protected against reentrancy attacks? And as a smart contract writer, what do I need to do in order to benefit from those defenses?
I'm not exactly sure what you mean. I mean, for example, if you think about the following scenario, you have a profile that's controlled by a single key manager smart contract. You have a 3 set of keys, right? That can control the profile. If you make a transaction from your profile to another contract that now calls back into your key manager, then that external smart contract does not have any permissions and therefore cannot call back into your key manager. So the permission logic within the key manager prevents anyone else from calling into your key manager. So we have looked at it in depth. We haven't found any reentrancy possibility. It's not an issue really in that setup. That we can
I noticed in the GitHub that there was actually different libraries that included reentrancy attacks in your GitHub. So it appears that they have been engineered. There's been like a call to a reentrancy asset and also to an Open Zeppelin reentrancy guard. And I'm
maybe
just
that's
wondering.
Maybe that's in the token contracts. Jean, maybe you want to answer that.
Yeah, sure. So when it comes to the universal profile, as Fabian explained, most of reentrancy is really limited by the fact that you have the profile that is owned by the key manager, and everything has to go through the key manager because most of these functions are marked as only owner. When it comes to so when it comes to reentrancy, everything to be reentered has to go through the key manager. So any contract that tries to reenter the contract needs this default set of permissions. When it comes to the reentrancy around the tokens, what happens is that the tokens, when the token contract basically call transfer assets, they trigger what Yamin was explaining. They trigger the universal receiver function. So this function, the only way reentrancy could happen is if the universal receiver delegate of this profile will have malicious code. But in the first place, what what basically we do with our base implementation is that you need in the first place to have a universal receiver delegate contract that you trust. You need to really be cautious in which universal receiver delegate account you will link to universal profile. That's really the way. To have this prevention mechanism, I would say.
But the thing is, for example, the token contracts, and maybe this is specifically what you're referring to, the token contracts do call universal receiver on other smart contracts. These other smart contracts could obviously try to call back into the token, right, to somehow transfer more than I do. Obviously, we do update the balances before we do the call, and I'm not sure if we use an OpenZeppelin guard for the reentrancy right now, but also in some cases, reentrancy is a feature, not a bug. For example, on the universal profile, you could literally allow a third smart contract to have a permission in your profile, and you actually want it to be able to call back into your profile. For example, you could say that your universal delegate has the allowance to even move assets on the behalf of the profile. So the moment somebody sends you a token, it could automatically be forwarded into another vault by your universal receiver delegate, right? That would be a wanted way where you want to have a re-entrancy into your profile. But for the token contracts, it's the default behavior, right? You update the state before you call the external contracts.
All right. Let me check if there's any more questions that we haven't answered yet. Let's see. I am not seeing any more questions. All right. All right, everyone. I really want to thank you, Jean, Yaman, and Fabian, for this great session. And part 2 will be tomorrow at 5 p.m. CET, but we will go ahead and announce it on Discord again, and also include the link to Air Meets for you to join. So, go ahead and join that tomorrow. And thank you so much for joining today's session. Thank you again, everyone. And until tomorrow, we'll have a good day. Bye, everyone.
Thank you, everyone. Thank you,
Thank you.
Jean and Yaman, for a great presentation.
Thank you, everyone. Bye.